Good afternoon, everybody. I hope you can see me, hear me. Somebody can give me a bit of a thumbs up to know, let me know if that's okay. Hi, hope everybody can see me and hear me. Welcome to this afternoon's webinar, Demystifying Corrective Actions and Root Cause Analysis. I hope you find this informative, and let's crack on. There we are. So the aim of this afternoon's webinar is to pass on some knowledge relating to root cause analysis and corrective action, to give some information on common tools for root cause analysis and problem solving. So to give some information about the disciplines for completing root cause analysis and corrective actions, and to raise awareness regarding some common issues people experience during these processes. So this is me. My name is Martin Little. I'm NQA's Field Operations Manager for our Southern region. I've worked for NQA for nearly 10 years now. I've been a lead auditor for nearly 20 years, and I've worked in and audited for a variety of industries for 30 years. I'm a lead auditor for the ISO 9001, ISO 14001, 45001 standards, as well as the automotive industry specific quality standard IATF 16949. So let's begin with some definitions. What is a corrective action? It's defined as an action that eliminates the causes of a non-conformity and prevents it from happening again, ideally. What is a non-conformance? This is when a requirement is not fulfilled. And what is root cause analysis? It's defined as a systematic process used to identify the underlying reasons for problems or issues, allowing for more effective and long-term solutions rather than just addressing symptoms. And here are some potential sources for non-conformances which you may have experienced during your day-to-day lives. Customer complaints relating to non-conforming products or services, suppliers or subcontractors providing non-conforming products or services, routine inspections which identify non-conformities, your own internal audits, audits that you might receive from your customers, external audits, third-party audits from organizations such as NQA or regulatory bodies, and possibly even reports from other people such as members of the public. All of these can potentially be sources for non-conformance identification. What can be the potential effects of non-conformance? They can be risks to health and safety. They can be risks to the environment. They can be breaches of legal requirements. They can be customer dissatisfaction, products failing or having limited use, an insufficient or incomplete service being provided, a loss of business, financial penalties and additional costs, legal proceedings being taken, damage to the reputation of your businesses, your organization, the loss of certification, the deterioration of morale within your organizations, and consumption of resources. So all things that we would very much like to avoid whenever we possibly can. ISO has a lot to say about this. So most ISO standards, if you're familiar with them, include a clause for non-conformity and corrective action. Typically, this is clause 10.2, but not always. Certain ISO standards, such as 27001, have it in clause 10.1, but always roughly in the same area of the standard. And the clause places the following requirements onto our organizations. It requires us to react to non-conformance and to act as applicable to control and correct the non-conformance, to deal with the consequences of the non-conformance, to assess the need for corrective action to prevent the non-conformance from recurring or occurring elsewhere, to review the non-conformance and determine what caused the non-conformance, this is root cause analysis, to see if this non-conformance could occur elsewhere, to take the actions needed to address the non-conformance and to review the effectiveness of these actions, and to make changes to management systems as needed. We're also required to document the non-conformance and the corrective actions we've taken in response, along with the outcome of these actions. Have they been effective? Have they not been effective? The non-conformance and corrective action clause of the ISO standard is typically followed by the clause for continual improvement. Whenever there is non-conformance, there is always an opportunity for improvement as well. These improvements, beyond addressing the non-conformance and preventing its recurrence or occurrence, are opportunities to improve still further and to enhance products, services, and processes to greater heights of performance and to further minimize or eliminate associated risks. I'm sure most of us are familiar with the PDCA cycle of Plan, Do, and Check, Act. Within this cycle, the non-conformance and corrective action requirements firmly sit within the Act part of the cycle. Continual improvement also sits within the Act part of the cycle. So remember, the more thoroughly and comprehensively you plan, the better things should work when you do. When you check, you should realize how effective your planning was, and then with the data that you gain, you can act to address non-conformance and to improve before going around the cycle again. ISO 45001 has the same sort of requirements, but it has some different terminology. It refers to incident investigation. So 10.2 in 45001 requires us to review incidents in the same manner, in the same vein as non-conformities. So what is an incident? An incident is defined as an occurrence that could or does cause injury or ill health. So from a health and safety standpoint, the standard requires us to see the potential for an incident to cause harm and to address it with the same rigor as if it had caused harm. ISO 45001 also has requirements for us to participate with workers and other interested parties when we investigate the incident's root cause and to identify suitable corrective actions, to review the existing risk assessments as needed, and to apply the hierarchy of control when taking corrective actions. We're then required to communicate actions to workers and interested parties so everyone is aware of actions taken and new or changed working practices. For anybody that might not be familiar, this is the hierarchy of control which I referred to. There are 5 levels to the hierarchy, ranging from most effective at the top to least effective at the bottom. The first control is the elimination of the hazard from the workplace. If it's not there, it can't cause harm. This is most desirable. Substitution comes next, where we replace the hazard with a safer alternative, something that might not be completely safe but less harmful than what we originally had. The third control is engineering, so we can isolate the people from the hazard using physical devices or processes. And then in fourth, we have administrative controls, where we change how people work to reduce exposure to hazards. So an example would be, instead of doing complicated assemblies at height, we might do the assembly work, or as much of it as possible, at ground level, and then just do the installation at height, instead of doing all of the fiddly assembly work at height, increasing the risk of a fall. And then in fifth place, the least effective is personal protective equipment, PPE, where we protect workers from residual hazards. So the hierarchy of control. How to address non-conformities. The first thing that we must realise is that non-conformities come in all shapes and sizes, from the very, very big and complicated to the very, very small. You should choose the right tools to address each non-conformance appropriately. Don't mandate the use of certain tools for every non-conformance, as they might not be appropriate to the task. It's best to have a few options available to you. So having the right tools in your toolbox would be a good analogy. We'll now have a look at some of the tools that you could use. So managing a non-conformance should be done via the following steps. You need to clearly identify the non-conformance and assign responsibility for addressing it. That could be via an individual or a team. The right people need to be involved to ensure the non-conformance is fully addressed. I'll come on to this in a bit more detail in a short while. You need to clearly define the non-conformance. Ensure that the facts are captured, not opinions, facts. You have to identify and deploy suitable containment actions. These address the symptoms of the non-conformance, which make sure that in the short term, it doesn't have a negative effect. Use the right tools to fully identify the true root cause or the true root causes of the non-conformance. There can be more than one root cause. Identify permanent corrective actions that will address all the true root causes to prevent the non-conformance from recurring or occurring elsewhere. Implement your corrective actions, and you must verify their effectiveness. If they're not effective, you need to go back to the beginning and start again. Once you've done this, you can then look to preventative actions. You can apply the corrective actions that have been proven to be effective to similar products or services or processes. This should prevent the issue from occurring elsewhere and help to drive continual improvement. Then document your actions, communicate your actions to interested parties, formally close out the non-conformance, and if you're working to ISO, review your actions and your non-conformities as part of your management review. So one of the common issues that people have when it comes to corrective action is the difference between correction and corrective action. Every non-conformance will have symptoms. These are the things that are directly affected by the non-conformance, and here's 3 examples. The first one is from a quality standpoint. Non-conforming products that are produced are quarantined and reworked to specification. The damaged tooling that produced these parts is corrected. So we've addressed the symptoms of that particular non-conformance, but not the root cause, which is why was the tooling damaged? How were the parts not being detected sooner? From an environmental standpoint, the oil spillage is contained, it's cleaned up, the waste that's generated from the cleanup is correctly disposed of, and all of the barrels of oil are moved to a bunded area. Those are the symptoms. The root cause will be, why were the barrels of oil not being stored in a bunded area in the first place? How did they come to get spilt? This is what we need to address to prevent it from recurring again. From a health and safety standpoint, the person that's fallen into the exposed trench has been given first aid and has been taken to hospital. The trench was cordoned off to stop anybody else from falling in. But why did the incident happen in the first place? Why was the person able to fall into the trench? Why weren't they paying attention and they missed the trench and fell headfirst into it? I mean, these are rather fundamental life skills. These are all corrections. They address the immediate effects of the non-conformance only. They correct what is wrong and they help prevent the non-conformance in the short term. None of these address the true root cause. Corrective actions address the root causes that allowed the NC to occur. These are permanent actions and they will require changes to processes and management system if you have one. Before corrective actions can be identified, true root causes must be defined. Only when we have these can we identify suitable corrective actions. Root cause analysis must be appropriate to the non-conformance that's being investigated. If the non-conformance is limited in scope, then a brief root cause analysis could be completed. An example would be an incorrect part number is given on a delivery note. The root cause can be as simple as they manually generated delivery notes and the person entered the wrong part number. It was a data entry error. Such a non-conformance doesn't require teams of people and lots of time and money to be spent. But your corrective actions should address the root cause, which is manual data entry. You could potentially look to having a scanning system that scans the part number and the quantities directly onto the delivery note, so nobody's entering the data. Or the delivery notes could receive a secondary check, although this is again is reliant on a human being and might not be 100% effective. More complicated non-conformities will require a more detailed root cause analysis. A team of appropriate, competent people should be involved in this exercise. Appropriate people could include persons affected by the non-conformance, the people producing the parts or the service, quality, health and safety, environmental people, process owners, area supervisors, support personnel, maintenance, logistics, HR, union representatives, and management. If you do involve a team in your root cause analysis, remember that everybody works differently. People will have different levels of experience and knowledge and familiarity with root cause analysis and possibly the tools that you're using. A common issue is that the people that are more familiar race ahead and the people that are less familiar can get left behind. So it's always important to remember everybody that's contributing to the process. Once you've assembled such a team, you can then take advantage of their knowledge and their experience, and that should help you in finding the true root cause. As I've said already, some non-conformities may have multiple root causes. All must be identified for corrective actions to be truly effective and to prevent recurrence and occurrence. Another common failure is that people go into these exercises assuming they know the root cause. They sit down, we don't need to do this, I already know what's gone wrong. Possibly you do. Possibly that's 80% of the overall issue, but there might be another 20% that you've never thought of. And if you go through this process, you'll stand a better chance of finding all the root causes and truly effectively addressing the non-conformance. Corrective action and root cause analysis tools, here's some examples. So PDCA, I've already mentioned, you can use it for root cause analysis. It's a very simplistic tool and it can be paired with other tools such as 5Y, which we'll come to in a bit. So following the PDCA cycle, plan, define your problem, collect your data and your evidence. Identify root cause through appropriate tools, brainstorming, 5Ys. Identify corrections to address the symptoms and corrective actions to contain the non-conformance and address the root cause. Assign responsibility for delivering on these actions. We've now got a plan. We can now do. Implement your actions, corrective actions and containment actions, and verify their effectiveness. If they're not effective, you need to go back and begin again. When you've implemented them, check, prove that they are effective. Internal audits can be used to verify the effectiveness of actions. Most people typically don't do this and will follow just a routine schedule of internal audits. But if you've had changes or non-conformances or performance issues in an area, when you've made improvements or corrective actions, internal audits can be used to verify that these are truly effective. They're a good tool for the job. You can now act. You can standardize your corrective actions, update your documentation, provide training, provide communication, and then apply your lessons learned to similar products, services, and processes. If any of this proves ineffective, then return to the first stage and start again. Here's an example of a PDCA. So quotations were not provided to clients within 48 working hours. A factual statement. Planning, 5 quotations were not provided to 5 different clients within 48 working hours by salesperson A. Quotation log was reviewed, detailing when these inquiries came in and the dates of quotations being supplied. Root cause analysis in this instance could be just brainstorming. Root causes: salesperson A was absent from work because they were ill. Suitable resource was not provided to process salesperson A's inquiries during their absence. This action is not captured in the sales process flow as it currently exists. Responsibility for taking this action has not been clearly communicated, and the risks associated with the sales process were not fully effectively identified in the beginning. So these are our root causes. This will help us and guide us to apply our corrective actions. We can then do: resource can be allocated to process the 5 overdue inquiries and update the quotation log. So this is addressing the symptoms. Sales manager can communicate with the clients affected to ensure they've had their quotes. You can now move on to permanent corrective actions. The sales process flow can be updated. Assign responsibility for providing suitable resource when a team member is absent for any reason. Update the process mapping process to ensure that all associated process risks are captured, so you don't have such a shortfall in any of the processes within the business. Check. You can complete an internal audit of the sales process 1 month or longer after the deployment of your revised process. You can increase the risk of the sales process because it's had non-conformance. You might increase the frequency of your internal audits from annual to 6 monthly for the period of 1 year. And the management team can monitor sales KPIs for responding to inquiries within 48 hours. That can be done on a monthly basis. You can now act. You can update the sales process, update the process mapping process, and communicate out to all interested parties. That should tie a nice, neat bow around it and get through most of the issues. A bit more complicated, a root cause analysis tool, Ishikawa or Fishikawa, as you can see why, cause and effect. It's a visual tool for root cause analysis. The tool resembles the skeleton of a fish, as you can see, and potential root causes can be categorized by areas, methods, machine, people, materials, so on. So within the head of the fish, you define the problem. You must clearly define it. So the problem could be: whilst working at height via a ladder, operator A dropped a hammer which struck the injured party on the head. The problem-solving team can then work together to identify potential causes for the problem. The various areas will give some guidance. So some potential examples could be: under method, there was no exclusion zone under the person working at height. The method, again, no requirement for person on the ground to wear a hard hat. Method, risk assessment, didn't take into consideration items falling from height. Under people, the injured party had not been trained not to stand or work underneath someone working at height. Operator A had deviated from the safe system of work and used a ladder instead of a MOOP. The MOOP that he should be using had broken down and was unavailable because routine maintenance had not been completed. And at the time of the incident, it was a windy day, so the environment contributed something to the incident. So the completed diagram could look something like this. This is just an example. So each of the potential root causes can be captured in the diagram. You can then investigate them and prove them to be valid or invalid. So you can just pile them all in there. Those that are proven to be valid can then be addressed via effective systemic corrective actions. So these could be: risk assessments reviewed and updated for working at height, consideration for tools falling from height to be included. Controls could include an exclusion zone of 2 meters underneath such jobs. Hard hats become mandatory PPE for all staff present, and the review of weather conditions before starting work. If the weather's no good, don't work. The safe system of work can be updated to include the above. You can communicate and train out the risk assessments and safe system of work to all applicable staff. You can provide counselling for operator A and the injured party in relation to this incident. You could increase site safety visits for operator A and the injured party for 6 months. Site safety visit increases for working at height. MOOP repairs completed and routine maintenance updated and provided to the maintenance manager on a monthly basis. and the working at height permit should not be issued unless the MOOP is available, people are competent, and the weather is deemed to be suitable. So just some examples of some actions. Moving on to 5 whys. This root cause is often combined with fishbone diagram to help drill down into the proven root cause identified. The process involves the problem-solving team asking why, not just 5 times, but as many times as necessary to drill down to the true root cause. This means that the root cause is found rather than just the symptoms of the problem being addressed. As I've already said, you can ask why as many times as you need to, but it's important to keep going until you reach the root cause. If you don't do that, your systemic corrective actions might not be effective. So a couple of examples based on the incident that we just saw. Why was the injured party stood underneath the person working at height? They were holding the ladder. Why was the injured party holding the ladder? To prevent the ladder from moving and the operator from falling. Why would the ladder have moved? It was a windy day. Why was the work being performed on a windy day? Because the weather conditions hadn't been taken into consideration. Why hadn't the weather conditions been taken into consideration? Because the risk assessment performed didn't consider weather conditions. Why didn't it consider weather conditions? Because the risk assessment was insufficient, because it had been completed, because it hadn't been completed by a competent person. And why wasn't the person deemed competent? Because they hadn't received suitable training and had their competence assessed. So systemic corrective actions would be mandatory risk assessment training for all staff who are working at height, annual refresher training, 6 monthly site safety visits to review competence, and also to review the competence of the process overall. That same 5 whys could follow a different path quite easily. So why was the injured party stood under the person working at height, holding the ladder? Why was operator A using a ladder? Because the MOOP was unavailable. Why was it unavailable? Because it had broken down. Why had it broken down? Because routine maintenance hadn't been completed. Why wasn't it completed? Because the maintenance engineer had left the organisation. Why weren't the responsibilities for MOOP maintenance reallocated? The maintenance manager had not hired a new maintenance engineer yet, and in the meantime, the responsibility had not been reallocated. So why wasn't it temporarily reallocated? It was ineffective management of change. So in this instance, change management would be part of your corrective actions to make sure that when changes occur, the company reacts as appropriate. And again, internal audits can be used to verify effectiveness. There are several other less well-known root cause analysis or failure analysis tools that can also be used. And here are a few examples. Pareto analysis is actually a very useful tool. It's often called the 80-20 rule. Basically, it means that typically 80% of the problem is caused by 20% of the contributing factors. By identifying these vital few contributing factors, you can focus your efforts and resource on addressing them, which will give you the biggest bang for your buck. If you focus on all the contributing factors at the same time, your resource could become stretched and you might not be as effective in addressing the issue that you're looking to address. So Pareto analysis can aid in efficient problem solving. So steps of Pareto analysis, as we keep saying, clearly define the problem, gather the data, categorize the causes, and then rank the causes. So this could be on frequency or severity. Create a Pareto chart, analyze the chart for the vital few, and then prioritize your solutions, prioritize your resource allocation. And here's a potential Pareto analysis for injuries that could occur on a construction site. So on the left, we can see occasions, on the right, we can see the overall percentage, and across the bottom, we can see the contributing factors. And from this data, we can see that the primary causes of injury are falls and the misuse of equipment. So by focusing your efforts on those 2 areas, you could effectively reduce injuries by nearly 60%. You could then do more Pareto analysis on falls and the misuse of equipment, such as where and when are the falls occurring? They're in the car park, they're in the early morning, they're in the evening when the light isn't so great. The floor of the car park is full of potholes and ruts and there's not sufficient lighting in the area. Which equipment is being used the most, being misused the most? Find out why, drill into it, and with this greater wealth of information, you can focus your efforts to best effect. We can also be proactive in our failure analysis. So rather than waiting for a problem to occur, it is possible to predict problems in advance and take proactive preventative action to stop the problem from occurring. Most common example of this is a risk assessment, typically used for health and safety, but can be used in any circumstance. And the 5 steps of generic risk assessment are these: identify the hazard or the problem, define who could be harmed or affected by the problem and how, evaluate the risk and identify appropriate controls, document findings, implement controls, review your assessment if needed. So here's a short example. Again, going back to working at height, who could be harmed? The person working at height or people below the person working at height. Risks are falls from height, resulting in injury or death, or items falling from height, resulting in injury and death. So controls that you can implement: a permit to work, the use of a MOOP for working at height, plus suitable fall arrest equipment, IPAF training for operators, tools to be secured along with parts and materials, prepare assemblies or sub-assemblies at ground level to minimize assembly time at height, exclusion zones, trained and competent personnel, and the correct use of PPE. By doing this in advance, you can potentially avoid the incident of somebody falling from height or being struck by something falling from height. So rather than waiting for it to happen, you've been proactive and stopped it before it's occurred. Another potential tool is fault tree analysis. We're getting a bit technical here, but it's only for a short while, so bear with us. These are complicated tools, and they do require some formal training experience to use them properly and effectively. Both tools can be used to analyze potential failures and to assess what controls can be put in place to eliminate the failures before they occur. So fault tree analysis first can help determine the root cause of failures and potential vulnerabilities in the system, aiding in risk assessment and reliability analysis. It's a top-down approach, meaning it starts with the undesired event, the thing that you don't want to happen, or the undesired event that has happened. So a system shutdown or a component failure, and then you work backwards to find the underlying causes. It's a visual system, and you generate the fault tree diagram as you dig into the issue. The diagram also uses logic gates such as and, or, and they're combined with the events that contribute to the top event. And here's a very short, sharp one. So in this instance, a car has hit an object and it was the driver did not see the object, or the car fails to brake. So why didn't the driver see the object? Object was just around the corner, or the driver was drunk, or the driver was asleep. Car fails to brake because it's going too fast, or the brakes are weak. So this FTA could then be progressed further to gain a greater understanding as to what's occurred. Why was the driver drunk? Why was the driver asleep? Why was the driver going too fast? Why were the brakes weak? And the deeper you go, the more information you'll gain, and the stronger your actions will become to prevent the issue from occurring or occurring. And then this is the last technical one, and then I'll call it quits. Failure mode and effect analysis. It's an automotive tool and technique. It can be used to critique the design of a product or a step within the manufacturing process. The FMEA considers a feature of each and then drills into the potential failure mode. It considers the requirement that must be met. So for a product, it might be corrosion resistance or the correct positioning of a QR code on the product. It then looks at the potential failure modes. So the product corrodes too easily, or the QR code isn't legible, or it isn't in the correct position. The FMEA then considers the effects of these failures should they occur. The product corrodes and a wheel falls off. So potentially that's a fatality, or the QR code can't be read and the product can't be identified, which is not too serious, it's more of an inconvenience. We can then score the failure mode for severity, what happens if it occurs, occurrence, the likelihood of it occurring, and detection. If it occurs, how likely are we to detect it? We typically score each out of 10, and then we multiply the scores together to generate an RPN, or a risk priority number. The bigger the number, the bigger the risk, and again, you can know where you need to focus your efforts. Severity obviously is the most key category to consider, because if it's going to be a fatality, you want to look at that first. Here's a quick example of what an FMEA would look like. We can see process steps, potential failure modes, potential effects, the severity of the effects, the cause mechanism, what caused it to happen, the occurrence, how likely is it to occur, if it does occur, if it is going to occur, what controls do we currently have in place, and then we can look at the current controls that we have to detect the issue. Then we can generate the RPN. With the higher RPNs or the greater severity, we can then see on the right-hand side of the table where we take our improvement action to reduce the overall risk. And again, we're being proactive rather than waiting for an issue to occur. Human factors. Human factors are playing a bigger part in non-conformance corrective actions today, but realistically they always should have done. So I'm sure there's possibly some people listening in that have listed the cause of the non-conformance, or seen from their suppliers the cause of the non-conformance as being human error. It's often given as the root cause, but simply stating human error means that your root cause analysis has not gone far enough. What allowed the human to make the error? Typically there are 13 recognized human factors that can contribute to human error, and here they are. So a lack of communication, so necessary information was not passed along. Complacency, a lack of focus from the individual. A lack of knowledge, where there's a gap in training or competence. They could be distracted by something. Somebody asks them how the football match went last night, or did they enjoy dinner at a certain restaurant that they'd been to, and whilst they're answering, they're not paying attention to the thing that you're doing, and the fault creeps in. A lack of teamwork, failure to work together to complete the task. Fatigue, being physically or mentally exhausted, can directly affect work performance. This can be caused by long hours, a lack of sleep, or insufficient breaks. If you've got a new baby in the house and it's keeping you awake all night because it's crying, or you've got an ill relative in hospital and you're not sleeping because you're worried, these can all contribute. A lack of resource, not having sufficient people, time and equipment to complete the task. Pressure, with unrealistic deadlines, pressure to work harder, faster, better. A lack of assertiveness, people not speaking up, not questioning instructions or orders, or questioning the actions of others. Stress, so it says a certain amount of stress is good. I don't like it, but there we are. But excessive stress has very negative effects, we know this. A lack of awareness, a failure to recognize a potentially dangerous situation. Norms, organizational culture, it's always been like that, we've always done it like that. And finally, the attitude of the person, a positive or negative attitude can directly affect work performance. And these are potentially some categories that contribute to human error. So don't ever put human error in, go deeper. In response to human error, what do we typically do? We provide knowledge and retraining as the only corrective action. That might not be enough. As I say, if somebody's got a relative that's ill in hospital, providing them training is not going to help in that situation. Potential corrective actions could include the redesigning of processes and the improvement of working conditions. Whatever human factor is identified, corrective actions need to be appropriate. And then problem solving. People often confuse problem solving with root cause analysis. Root cause analysis is typically an element of problem solving, but it's not the whole gig. Two popular problem solving tools are 8D, or the 8 disciplines, and A3. The 8 disciplines, the benefits of these, it's in a structured approach to problem solving, which makes it easier for people to follow. It's team orientated, it focuses on root cause analysis, and it includes preventative measures as well as corrective to help drive continued improvement. And these would be the 8 steps. So D1 is you put a suitable team together. D2, you clearly define factually the problem. D3, you implement suitable containment and verify effectiveness. D4, now you do your root cause and you choose your systemic corrective actions. Verify the effectiveness of your corrective actions, implement them. In 7, prevent recurrence by applying lessons learned to similar products and processes. And 8, always remember to thank the team and celebrate the success of your hard work. That's a typical 8D template. All these sort of things can easily be found on the internet. They're readily available, but it's a structured approach to problem solving. A3 is a bit more exhaustive. It's an improved problem solving. It improves problem solving within the business via its structured approach. It's very visual in nature, which enhances communications because people like pictures rather than words. It encourages collaboration and teamwork. It champions the PDCA approach, and it empowers people in problem-solving activities. So once people have been trained in how to do good A3, good 8D, then they can go and do it without significant supervision or management. Steps of A3, again, problem description, clearly state the facts. It looks at the current state as things are today, and you can use data and images and graphs and whatever. It then looks at the future state, what you want it to be tomorrow after you've made improvements. Then comes root cause analysis. Containment, as ever, define who's going to do what and by when to contain. Identify your permanent corrective actions to address the root causes. Come up with your implementation plan for these actions, who will do what and by when. Verify your actions, prove that they have addressed the root causes, and then take your follow-up actions, apply your lessons learnt, standardize, document, and communicate. And there's an example of an atypical A3. And as I say, a lot more pickies on that one. Further information on everything that I've touched on in this webinar is available online. None of this stuff has been created by me. It's been around for an incredibly long time. Templates and tools are also available online. They're a Google search away. This webinar is not exhaustive. That's the right exhaustive, yeah. There are other tools and techniques out there. You just use the ones that you're most comfortable with, the ones that work best for you. There's nothing in ISO that says you must use this tool or that tool. As I say, it's what works best for yourselves. So you're probably fed up of listening to me drone on. So thanks for your time and your attention. And I'll open it up to questions and I'll do my best to answer any that you may have. Rightio. So I've got some questions here. Oh, the thing keeps moving. All good. Yes, yes, can hear me, can't see. Okay. There's a recording of this which will be made available. It says, please can we have the slides? There'll be a recording that's made available. I believe it's through the NQA YouTube channel. I would add repeat occurrences that waste time and effort. Yes, correct. That was Steve Lacas. We don't want recurrences of issues. If we have recurrences, it means that we haven't done the process effectively. And we certainly don't want to be going over old ground. It's very annoying to clients if they have repeat concerns. Is a near miss an automatic non-conformance, thus requiring root cause analysis and effectiveness review? Again, depends on the nature of the near miss, but yes, a near miss has the potential to cause injury and harm. So yes, you must deploy the appropriate tools you have available to address the near miss, because next time it might not be a near miss, it might be a hit. What are the best ways to verify effectiveness? It can be observation of a person doing a task. It can be the product that they produce from that task being independently verified. You can use measured data. So before, if there was a high reject rate on a job and you've introduced corrective actions, when you look at the rejects or rework coming from that, it could be greatly reduced. Internal audit, again, is another tool that's very good at verifying effectiveness. Yeah, it depends on the nature of the root cause and the corrective actions that you've implemented. Okay. On this slide, can you identify which correction and which the corrective action in an example? So okay, correction is addressing the symptoms of the non-conformance. Corrective action is addressing the root cause. So like I gave an example there of an oil spill on site because a barrel of oil was left in an exposed area and wasn't bunded. The correction there would be to clean up the oil spill, move any other barrels to the correct location and bund them, and then deal with the hazardous waste that was created by cleaning up the oil spill. The root cause, the corrective action, would address why the barrels were there in the first place. So that's what you want to get to ideally prevent it from recurring again. It could be that there's just been a delivery of oil and it was put there temporarily whilst you were waiting for somebody to move it to the stores. So your corrective action might be to not store it in that temporary location and to take it straight to the stores by scheduling your deliveries of oil, and then the storeman's available to put it away straight away, or have it delivered closer to the stores and put it away straight away. Again, it depends on the issue. Okay, just scrolling through. What kind of evidence will auditors look for in terms of us using these tools for root cause analysis? Evidence will be the effectiveness of the corrective actions. The auditors will be looking to see that the issue hasn't recurred. If that involves training and awareness, or updated work instructions, or what we refer to as poke-yoke or error proofing on processes, the auditor who's chosen the non-conformance as a sample during their audit should follow those corrective actions to where they're being deployed. It might be a case of, I had a client recently that had an incident which involved a fall from height, and it was very significant in nature. When I went out to audit a crew of their employees working in the field, I initially observed the signing on of the job, the root cause that was done, I then asked them if they were aware of the incident and the new protocols that were put in place, which was a heightened form of risk assessment for the need to work at height, and how they reviewed the tasks to be done during the job. And they were all aware, they confirmed their awareness, and then I observed those activities actually being undertaken, which was, in that instance, very effective. Shared, okay. I'm just looking for questions. Do you have any templates for corrective action, preventative action, or FMEA? As I say, that all of these tools are time honored. They've been around for a very, very long time. If you just Google process FMEA, design FMEA, 8D, 5Y, A3, whatever it is you're interested in, you'll find it within seconds, because it's been around for so long. It's all readily available and it's all there for free. Does Six Sigma play a part in this as well? Six Sigma can. Six Sigma obviously is a heightened state of capability. So once you've made your corrective actions, you might choose to go further and enhance capability. So yes, Six Sigma definitely can be. Oh, can you please provide best corrective action for human error factors? Again, it depends on what's contributed to the human error. Human beings are complicated things. You know, you can have incidents where someone's doing a bad job away from specification, and when you stop and you talk to them, you find that, you know, they might be having problems at home. They could have financial problems. They could have, you know, got a drinking problem or a gambling problem, or they could be going through a divorce, or they could have relatives on, you know, palliative end of life care and things like this, things that they weren't willing to communicate to you. Until you start that dialogue to find out why, you won't actually be able to say what the best corrective action is. But obviously we have to be supportive and understanding and considerate, and give people the time to heal and get well. So in those circumstances, you might consider what you might refer to as light duties. You know, if you had somebody who, you know, was going through a tough time, you probably wouldn't start putting them into high pressure or high risk environments, because their mind might not be on the task. So you'd have to analyze and go from there. Which step would be used to document an emergency response action, which normally takes place prior to a containment action? Which step would be used to document an emergency response action? I'm afraid I don't understand the question. Maybe I'm just being a bit thick. Is there a hierarchy starting point of problem solving tools? As I say, PDCA is a very fundamental tool. It's short and sharp. 8Ds and A3s require a bit more experience and familiarity with to use well. Where can you get further information on training on more in-depth root cause analysis? In the UK, for automotive, there's an organisation called the Society of Motor Manufacturers and Trainers, the SMMT. Their training wing is called Industry Forum, and they have very good, very in-depth problem-solving root cause analysis training available. How to define observations, minors, and major non-conformities? That's greatly dependent on who's doing the audit. If I'm doing a third-party audit, then I've got clearly documented guidelines as to what constitutes an observation, a minor or a major. If you're auditing yourself internally, then you're not bound by those sort of guidelines. An observation would typically be something that is compliant, but there might be a better way of doing the process where you could potentially eliminate some waste. A minor non-conformance typically is singular, lower in risk, lower in scope. So you might look at 6 training records and you find that 2 aren't accurate in line with the training that the individual has received. Such an example could be a minor non-conformance. A major non-conformance are the flip side of minors, so they're bigger in scale, bigger in scope, higher in risk. They could involve significant legal breaches. A process that has completely broken down. So if you go to audit, internal audit, and there hasn't been any internal audits done in 9 months, the process has broken down, it's a major non-conformance. If you find the same minor non-conformance again and again and again and again and again and again and again, then that would indicate that the process that's giving rise to that non-conformance has broken down, and again could be a major non-conformance. Shipping non-conforming product or providing non-conforming services to customers, these can be major non-conformities. So there are definitions out there. Met with pushback regarding human error not being a root cause. Yeah, any thoughts on how to show my team what we need to go deeper into to reach that point? Yeah, well, just pass on the information that we've shared in this webinar, or again go online and Google those 13 categories of human factors, as it were. If you start to work through those given your circumstances, you'll probably quite quickly identify that could possibly be one, that could possibly be one, that could possibly be one, and then you could then dig deeper into that to establish the facts. Root cause and corrective action to avoid counterfeit materials in manufacturing company. Don't know where to begin on that one. On an instance by instance basis, if you have counterfeit materials, then obviously you could do your corrections, you address the symptoms, quarantine, isolate, dispose of the counterfeit materials, and then begin your root cause analysis. It's not something that I've actually come across myself. Can a corrective and preventative action be directly used without going through the NC process? Can these principles be used for 13485 as well? Yes, all of this is perfectly applicable to medical devices 13485. Can corrective and preventive actions be directly used without going through the NC process? I think you might struggle to identify effective corrective and preventative actions without going through the NC process. It's obviously that process that gets you to what actions are needed to address your true root cause. And yeah, I think we'll call it quits there. Thank you for your time and attendance. I hope there was something in there that proved useful to you, even if it's just some awareness of the discipline, the steps to go through, taking the time, making the effort, and hopefully it pays dividends to you in the long term by not having recurring issues, people all going home from work safely at the end of the day, the environment being protected, your businesses, your reputation, your bottom lines being protected. So hopefully there was something in there that was of use to you all. So I'll say good afternoon, and for those people that we haven't responded to, we've got the questions here, and we'll be in touch. So thanks very much. Have a good day. Bye.